Welcome to part one of exotic options. This is part one of 2 videos covering these options. These options will provide us a deeper understanding of standard or plain vanilla options. So that's what makes this video and the next one, part 2, really interesting, because I've selected and picked particular exotic options that will give us deeper into intuition of standard options. There's literally hundreds of what we call exotic or flavored options, and so you could get lost in all of them. I'm going to pick out the more popular ones and the ones that again give us deeper understanding. The prerequisite material for the video is you need to have a basic understanding of the binomial option pricing model and the Black-Scholes-Merton model, which you can find videos on YouTube for these models that I've explained. Now, let's look at this, what we're going to cover here, a little more detail. Okay, in part one, let's look at what we'll cover. We'll start off by covering asset or nothing options, and they're often denoted as AON. Asset or nothing options, where, you know, if the stock price is above the strike, you get the asset. You don't pay any strike. You get the asset, and that's it. If the option is out of the money and the stock price is below the strike, you get nothing. With a cash or nothing option, you basically get a cash amount if the stock price is above a strike or some reference. Basically a reference number, and so those things pay off a fixed amount of cash if it's in the money, and if it's out of the money it pays nothing. So these are labeled CON, cons. Okay, these are examples of what we call binary options, because it's either you get the asset or you get nothing. In this case, you get, in the other one, you get cash or you get nothing. So they're binary, or often called digital options. Okay. Now, the next set of options that we're going to look at here are what we call path-dependent options. And we're going to look at Asian options, which are going to look at the path. What these? Well, let me tell you what all of these do. They all basically examine the path at which an option follows in order to get to its terminal value. So when we did the binomial, when we did the binomial with the standard option, plain vanilla option, all we did was we looked at the payoffs at the terminal values at the end and discounted them back. And that's what we did. We didn't care how we got to where we were here, how we got to the end. We just cared that we were at the end. These were not path-dependent options. Now when we look at Asian lookback and barriers, the value of the option depends critically on the path it takes through the lattice work. For a really brief example, there is a difference between going up and then down, right, versus going down and then up to get to this point. So what you're going to find is with some of these options is you're going to find that there's a payoff for going up and then down, and there's going to be a payoff, separate payoff for going down and up. And so I'll explain that in this video, why that is and the purpose of it. And then what we'll do is we'll look at barrier options, which are pretty cool because they allow you to chop off or add components to the lattice work. So you may have a barrier that, for example, that if you cross this barrier, the option dies. So the option's alive right here. It's alive, but if it crosses this barrier, then the option would die. And once it's dead, it's always dead. You could have the barrier anywhere here in the lattice work. And so what it does is if this dies, it cuts off this payoff, and all you're left with is these payoffs down here. Okay. You could also have options that are initially dead, and then they become alive once they cross a barrier. And so if this option becomes alive once it crosses the barrier, this is the only payoff that you'll end up generating. So we'll cover these in more detail in this video. The thing that you want to keep in mind is there's a separate video on exchange options. Exchange options are really cool options, but they're more detailed. They're a little more complex. They're slightly more bizarre, I think, mentally, to try to wrap your head around. So that's a separate video. Okay, so let's start into the binary options. We'll start with an asset or nothing option. An asset or nothing option, A-O-N. Okay, an asset or nothing option. Let's look at call options. We're going to deal with call options throughout this chapter. A call option is an option that pays the holder 1 unit of the underlying asset or its equivalent in cash value if the asset's price at expiration exceeds the strike X, and nothing if it is less than X. What that means is, let's look here. Let's just look at a payoff graph here. And so we write our standard payoff graph. This is dollars here. The payoff's on this axis. Here's the stock price. And here's the strike to this option. Here's 0. And let me just, to make it more concrete, let's say the strike is $95. Okay? So and we're going to look at a long call, basically. We're going to be long. And so the long call, according to the definition, if the stock price at expiration, time T, is greater than X, the payoff is going to be ST. If the stock price is less than or equal to X, the payoff is 0. Now compare this payoff to a standard plain vanilla option. And remember, when the stock price was greater than the strike, the payoff you got was the stock price minus the strike. There's no minus the strike here in an asset or nothing option. You just get the stock or you get nothing is what that says. Therefore, your payoff is going to look like this. And this is at 95 right here. So you're going to get something that's worth 95. That's this element right here. And then if the stock is less than the strike, you get 0. You get nothing. Okay, so you get this discontinuous, this jump in the payoff from a asset or nothing option. Now that's if you're long. If you wanted to look at a short, for example, it's going to be if the stock price is greater than X, you're going to get minus ST. You're going to have to pay the stock price. And if the stock price is less than or equal to X, you get nothing. So what that'll look like is something that looks like this. It almost looks like a written call component to it. So you get nothing if the stock price is less than the strike, and you get minus ST, and the higher the value of the stock at expiration, the more negative you go. Okay, so that's not too bad. Let's look at an cash or nothing option. Cash or nothing option. And we're going to deal with a call again, and this is an option that pays the holder a predetermined fixed amount of cash, often equal to X, the strike, but it could be any amount. We'll just assume it's X. And it'll pay this off if the asset's price exceeds X at expiration, or nothing if it's less than X. Okay, so what this looks like, the graph will really hit it home, I think, for you. Again, the standard sideways T, X will make a concrete example, 95. Here's the payoff in dollars. And so what we have is we're going to get $95. If the stock price is above the strike here, we're going to get $95. We're going to get the strike. That's a payoff of 95. It's flat here, and it continues to go up. Okay, the payoff will be 0 if it's less than. So if the stock price is greater than X, we'll get X for the long cash or nothing option. And if ST is less than or equal to X, you get nothing, which is right here. Okay, so again, a discontinuous, but instead of having an upward sloping line, it's a flat line. Okay, now if you're short this, what will happen is you're going to have to pay. It'll be ST greater than X, you'll pay X. And if ST is less, stock at expiration is less, you pay 0. So it'll look like this, where this is minus 95. Okay, so graphically, and there's the payoff structure of those two types of options. Now, what's really cool is if we take the long asset or nothing, if we take this guy right here, and we combine it with the short cash or nothing, let's see what we get. Let's see if I can draw this on the graph here. Okay, so we basically had a long, this was the asset or nothing, and then we're going to have a cash or nothing short, nothing, and then this is the stock price. And then if we combine these two, basically add these two up, basically what we have is we're adding 0 and 0. When we're below the strike, we're adding 0. So you're basically right here. And then what's going to happen is we're going to keep this. This is a slope of 1, and then this is a slope of 0. So when you add the slopes, you know you're going to get a slope of 1 by adding these two lines up. Okay? But now look what happens. This negative number of 95, negative 95, is going to pull this whole line. This line, it's going to drop and pull down. So it's going to look like this. And that's the payoff of a long asset or nothing plus a short cash or nothing, provided they have the same strike and the same underlying for it. And that's important to know, is the same strike and the same underlying on it. And that's what happens. So what do you see there? Well, that's the payoff to a standard plain vanilla call option, where we have, remember, the payoff is if the stock price at expiration is greater than X, the payoff is the stock price minus X, or if the stock price is less than or equal to X, the payoff is 0. Well, let's see. When the stock price is less than the strike, we're here. And then when the stock price is greater, you're going to get the stock price minus the strike, and that's what this distance is right here. So what you see is a standard plain vanilla option, call option, is nothing but a combination of two binary options, an asset or nothing long and a short cash or nothing option. Okay, so that's extremely insightful because that's what we've been dealing with in previous chapters. Now let's go a little further and let's look at it a little more carefully here, and I'll look at some payoff scenarios here. So look, this is what I'm going to build a little table here. So here we have the option. Here we have a long asset or nothing. Here we have the short cash or nothing. And here we have the portfolio. What I mean by portfolio is it's a portfolio of a long asset or nothing plus a short cash or nothing. Okay, and we're going to look at the current value. And then we're going to look at what happens when the stock price is less than strike, and what happens when the stock price is greater than the strike. Okay, now with the long cash or nothing, long asset or nothing, when the stock is less than the strike, the payoff is 0, and when it's above, it's simply ST. Okay, not too bad. Now, with the cash or nothing, the short, it's going to be, the payoff is going to be 0 when the stock price is less than the strike, as you can see, or it's going to be minus the 95, which is minus the strike in the example that I provided. So if you add these up, what do you get for the portfolio? Well, no matter what happens, if the stock price is below the strike, you're going to have a portfolio that has a payoff of 0. And if the stock price is above the strike, the long asset or nothing pays off stock price. The short is going to pay off a minus the strike, and so it's ST minus X, which again, just in another way, is telling you that that's the same payoff structure as a standard plain vanilla call option. And so what we have here is now relating this to the Black-Scholes model. This is the current value of this payoff here. This payoff right here is going to be stock price today, okay, multiplied by the probability that the option is going to be above the strike right here. It's probability it's going to be above the strike, and there you have the current value of the long asset or nothing. Now, what is the value of the short cash or nothing component? Well, it's the strike price with the present value. And so remember, E to the risk-free rate over T periods, this is nothing but taking the present value. This is the discount factor times the strike that you're going to get at expiration. So this component right here is the present value of the strike. Just like this stock price, it's the present value of the stock. Here's the present value of the strike, and then we have to adjust it by the probability of having to pay the strike at expiration. And when you add those two up, well, what do you get? Well, I can't write it here. It's running out of space. It's going to be S ND1 minus XE minus RC times T ND of 2. And there you have it. That is the formula for that is the Black-Scholes model. And remember, the Black-Scholes model is for a standard option, and this is a standard call option formula. Okay, so now we can look at this a little more closely by comparing it to the binomial model. And so let me give you an example with the binomial model. And I have to draw, well, let me give you the parameters of this model, this example. I'm going to suppose that S equals 100. I'm going to suppose that X is 90, the strike is 90. RC, continuously compounded rate, is 2%. I'm going to assume it's a 2-year option, and there's going to be N equals 1 step per year, so we're clear here. And the sigma, the variability at each step, is going to be about 9%, which implies that the up move is 1.10, and the down move is going to be 1 over 1.10, and that will be 0.9091. Okay, so that's the parameters of the binomial. Let me draw the lattice. So that should be familiar to you. So we start off, the stock price is 100. It can go up to 110 here, and then another period, another year, it can go to 121. So that would be the stock price. Now, if it goes up, it goes down, it'll end up back to 100 because it goes up 1.1, but goes down about nearly 10 or 9%. It drops back down to 100. And here, if it starts off at 100, drops down to 90, I'll put it here, $90.91. If it goes up, it's going to go to 100. If it goes down, it'll go, if it goes down another 9 or 10%, it'll go to 82.65. So that's standard binomial just for the stock price that we need to value the option. Now, let's look at this. Now, let's look at the standard before we go further. Let's look at standard payoff, and that's for a standard option, standard call option. It's going to be the stock price minus X if it's in the money, or it's going to be 0. And so in this case, it's going to be 121, the stock price at expiration. So this is stock price at expiration minus the 90. So this will be 31. This will be the stock price of 100 minus the strike. This will be 10. And this payoff will be 0 because it's out of the money. Okay, it's out of the money. So that's just a reference for the moment. Let's look at the asset or nothing. Okay, the asset or nothing is, well, if the stock is above the strike, which is 90, it's going to pay off the stock price. So it's going to be 121. It'll be 100 because 100's above 90. It's going to be 0. And for the cash or nothing, and this is a cash or nothing that's going to pay 90, what will happen is the payoff will be 90. We'll receive, because we're looking at long options. We're going to receive 90. We'll receive 90. We'll receive nothing because the option's out of the money. Now, once we have all these payoffs, all we have to do is we'll just discount them at the risk-free rate back down, and we'll figure out what is the call price here. And so we actually have three different options. We'll have the plain vanilla standard option, like we've been doing in previous chapters. Then we'll have the asset or nothing, and we'll have a cash or nothing. Okay? So, before we go further, we need the probability of an up move. And the probability of an up move, if you recall, it's 1 plus R over N minus D over U minus D. And that's 1 plus the 2%, and it's 1 step per year. Okay, minus 0.9091 divided by 1.10 minus 0.9091. That is 0.581. So the probability of going up is going to be 0.58, which implies the probability of going down, 1 minus that, is going to be 0.419. Okay, from that we can discount all of these cash flows back and look at them a little more carefully. So if we do the standard plain vanilla option, we'll just discount the 31 and the 10 back. Okay? And that is 58, the probability of going up twice to the 31 is going to be 0.581 squared, right, times the 31 plus, there's two ways to get to this $10 for the standard payoff, going up, down, down, up. And so it's 2 times 0.581 going up, then down, which is the same as going down then up, just reversing these, times the $10, plus it's a 0 here. This is 0 where it's 0, so I don't have to really much worry about that. And then we have to discount it. Okay, so this is the expected value at expiration. Now we can discount this at the 2% for 2 years, and what this boils down to is $14.74. So this component, this is going to be worth $14.74 roughly. Remember, binomial is an approximation of what really is happening. It's only a two-step approximation where the Black-Scholes is an infinite number of steps and is more precise. But this will be a reasonable estimate within maybe 20-30 cents difference. Okay, so keep that in the back of your mind. 1474. Let's look at the asset or nothing, and the asset or nothing is going to be the same 58.1 going up twice, up this tree, twice. Okay, we're going up, up, and what are we looking at a payoff? We're looking at a payoff of 121. Okay, and that payoff is times 121 plus here there's going to be two ways to get to this $10. 1, 2. So 2 times 0.581 times 0.419 times the $10 plus 0. Plus, oh, I'm sorry, $100. It's 100. It's 100 that I'm doing, not 10, 100. And then it'll be 0 at the end because the payoff here is 0. And we discounted at 2% for 2 years, and the value of this asset or nothing is 86.05 cents. Okay, so we didn't have to subtract off the strike, which is why it's so much more. Cash or nothing is going to be on following the up node is 58.1 squared, 0.581 squared times the 90. So here I am. I'm going to discount this guy and this guy and this guy back. And again, it's 2 times 0.581 times 0.419 times 90 plus 0. Discount the whole thing back 2 periods at 2%, 71.31. And so now we have the standard call, right, would be an asset or nothing minus a cash or nothing, because that's the short cash or nothing. This turns out to be 86.05 minus 71.31. That equals 14.74. And there you have it. It matches. Oops, sorry about that. 1470, that's a 4 there. It matches the standard option. So here we got digital options. They're a way to disentangle or pull apart the payoffs of an option. So it gives you some great insight that a standard call and it's, you do the same thing for puts. Have this neat thing about it. You can add the two together again. So the course that I teach is financial engineering, and what we're seeing is you can pull apart and get pieces of a standard call option, and you can get the pieces, add them together, and develop nearly any payoff structure that you would like, and payoff structures that are different than the standard call or standard put that's available. Now, one other thing, we could do this whole thing. Now, I did this all binomial. Let me flip over to do the Black-Scholes model for these quickly. And I'll do the Black-Scholes for the standard call. I'll do the Black-Scholes component here, the Black-Scholes component here, and we'll see that they all tie together just like they did for the binomial. And they should. So, remember, the standard Black-Scholes model is this. So the first thing we need to do is calculate the D of 1, and the D of 1 turns out to be, so it's the log, remember, of S over X plus R plus sigma squared 2 times T over sigma square root of T, and that turns out to be the log of 100 divided by 90 plus 0.02 plus 0.0953. I'm running out of space. 53 squared divided by 2, and multiply this whole thing by 2 years. Divide it by 0.0953 square root of 2, and we get a D of 1 equals to 1.143. D of 2 is equal to the 1.143 minus sigma square root of T, 0.0953 times the square root of 2, and we get 1.008. Now, drop this into the cumulative normal density function. The cumulative normal density function for this will be, what is it here? 0.8735. So remember, that's the cumulative area under here. So this is 0, this is 1.143. This area cumulatively to the left is 87% of this distribution. Okay, and when we figure out ND of 2, so we're a little bit further here, 1.008, what is the area to the left? That is 0.8433. Okay, so therefore we can calculate this. We can just plug the numbers in. We got them all now. And so C equals 100 times 0.8735 minus 90 times E to the minus 0.02 times 2 times 0.8433, and we get 1441. So pretty darn close to what we got here. I mean, we're off about 33 cents using the, well, remember when we did the binomial. Okay, again, that difference is due to the fact that we did 2 steps instead of an infinite number of steps. Okay, so now what we should see is when we calculate the asset or nothing using the Black-Scholes, and we subtract off the cash or nothing using the Black-Scholes, we should get 1441 here. Let's see if that happens. So the asset or nothing is S and D of 1, right? And that's going to be 100 times 0.8735, and that's 8735. And then the cash or nothing is X E minus RC times T, and D of 2, 90 times 0.961, that's 0.961 is this discount factor basically, times the 0.8433, and we get 7292. And so the standard call is going to be 8735 minus 7294. That's 1441, and bam, we got it. Yeah, so we nailed that one, and we got it. So there it is, right there, the same number we came up with earlier. Okay, so those are examples of binary, just 2 examples of binary options, and I just selected, out of all the binary options that could be out there, I selected 2 that get right at the heart of the intuition for a standard call option. Now let's look at some path-dependent options, to gain more insight into how options work. Okay, path-dependent options. Remember, there's Asian, lookback, and barrier options are the 3 that we'll cover. So let's look at the Asian. Okay, so these Asian options are options whose payoff is based on the average price experienced by the underlying during the life of the option or some other specified period. So what Asian options do is there's an averaging effect, and the averaging effect is throughout the lattice. So it's best to show this through a binomial example, and that's exactly what we'll do in a second. But let me talk a little bit about the various types of Asian options that exist. We could have, for example, call options, right, where the payoff is the maximum of 0, or the stock price average, and that average price would be the average price from the beginning, and at the time the option is created, to maturity, and then minus a strike. So that would be a call. A put, for example, would be the maximum of 0 or X minus the average stock price over the life of the option. Okay. There are also, by the way, average strike options. So these, by the way, these are called average price options. These two, because we're taking an average in those two areas. There are other types called Asian options called average strike. And so for the call, the payoff would be the maximum of 0 stock price at expiration minus the average of the stock price. So this guy is taking the place of X. And for the put, it would be the maximum of 0 S average minus ST. Again, there's the replacement for the strike is the average stock price. Okay. Now, Asian options typically have the valuation is typically determined through a simulation, and meaning there's no neat, clean formula. You know, like the Black-Scholes model of there's no neat, clean formula for valuing these. So you have to simulate them. Now these Asian options, what's interesting about them is you see, I mean, in each one of these cases, you see that there's an averaging effect going on with these Asian options. And so extreme payoffs like you might see with, you know, a standard call option when you go far up and deep and up, they don't exist in these options. Because there's an averaging effect. So the extreme payoffs at the up, you know, high up, like up, down, those things don't happen. They're all smoothed out with these averages, that has important effects on their prices. Now these Asian options, you think like, well, why would you ever want to have one of these? Well, what's interesting about these things is they're great hedges, and a really good example would be, let's say you're a large bakery, and you buy wheat every month, and you buy it every month, and the price of wheat varies obviously monthly. It's going up, it's going down, and so you're paying a high price, you're paying a low price depending on which month, and so if your demand is relatively even, then what you're really doing is you're really paying the average price of wheat over the life, you know, over a particular year. So you're paying an average price. Well, look, here you got averaging of prices going on here. So then the Asian option makes for a good hedge. Whereas with standard options, you're just looking at a payoff at the end, at expiration, at a particular point. It could be very different from the path that the option took over a particular year. Okay? So now let's do an example. And I'm going to continue with the example we used before. For the moment, we're going to continue with that example. So here we have stock. We got the stock price of 100. We got X is 90. We have U is going up. The up movement is 10%. Down movement about 91% of the original price. We're going to have T equals 2 years, 1 step per year. Okay, and so again, let's do the lattice, and here we have it starting off on 100, 110, 121, and this will go to 100, and this 100, and this will go to 82.65. This is 90.91. Okay, so there we have the stock laid out on the lattice work. Now, the payoff, we're going to look at an average price call. Okay, and then we'll look at briefly here an average price put, kind of running out of space here. Okay, so now let's look at how to calculate the payoffs. Once we calculate those payoffs, it's like we were before. We just have to discount them back, assuming, you know, that method that we've been dealing with since we started binomials is discounting through risk-neutral probabilities and a risk-free rate. So here, let's take a look at the calculation here. So remember, the formula is going to be the maximum of 0, or the stock price average minus the strike. Okay, and so what we need to do is we need the average of the stock price here, here, and here. And it turns out that that average stock price is, let's see, that average stock price is 110.33, and the strike is 90. So obviously the maximum of this is going to be $20.33. So $20.33 is the payoff for the average price call in that situation. Okay, so notice again, the average had a the path is what determined this average price. Now let's look at the average price, the payoff here. Now here it gets a little tricky, because the average price going up and then down is different than the average price going down and then up. So we're going to have two different payoffs for this node. Okay, and let's calculate them. So we're going to look at the maximum of 0, or the average of 100 plus 110 plus 100, and that average is 103. Okay, so 103.33 minus the strike of 90 means that this is 1333. The average for this is going to be 100 plus 90.91 plus 82.65 divided by 3, and we get an average of 91.19 minus 90. That happens to be $1.19. Made a mistake there. Whoa. This will turn out, this is $1.19. I'm sorry. So this is an average of 100, 90, 91, and the 82. This is $1.19. This guy here is going to be the maximum of 0 and an average of 100 plus 90.91 plus 100 divided by 3 gives me 96.97 minus 96.97. So this is $6.97. So you can see how you get to this payoff is crucial in determining these Asian options. The path is very important. Okay, so now all we have to do is discount these cash flows back, and the probabilities are the same. We'll write here Asian, give you a little space here, and so the probabilities are 0.581 squared, okay, to get to the $20.33 plus 0.581 times 0.419, the probability going up, probability going down, times the 1333 plus down, up probabilities, 0.419 times 581 plus 5.1 times 6.97 plus the probabilities here twice, 0.419 squared times the payoff of $1.19. Take all of that, discount it at the 2% rate, and by the way, I don't think I put it up here, R equals 2% per year, and we square that, and we end up with a price that is $11.55. Okay, and that price is a bit less than what we looked at for the standard option. The standard plain vanilla guy was $14.74. So we see what you see is the difference here is the averaging effect is reducing the price of the option. So these options are a bit cheaper than your standard option, your standard call option, because of that averaging effect. So the point is, for speculative purposes, you might want to use standard call options before you would use an Asian option, because the Asian option is averaging things out. But the Asian option is probably better for hedging, especially if you're hedging something, purchases over a period of time. Now, for the average put here, let's calculate the average put now. So what we're going to do is we need a maximum of 0, or now we're going to use the strike here. So I'm using this formula, by the way. It's 0 versus the strike minus the average price. So the strike is 90 minus the average price, and the average price on the upswing was the double upswing. That was 110.33, and so that means it's a payoff of 0, because this is actually negative. So the payoff is going to be 0 here. We'll do it again for the next node. 90 minus the average of 100 plus 110 plus 100 divided by 3 is 103. And so that payoff is 0. Because that's negative. Look at the next node, 90 minus, okay, let's average 100, 90.91 and 100. That's 97.3. And so that's another payoff of 0. And then let's do the last node here, 0, 90 minus, going to be 91.19, and that is going to mean a payoff of 0. Oh wow, so what's interesting is the average price put in this particular example, where we start off with a stock of 100 and a strike of 90, that option is worthless. We don't have to do any discounting back of all these payoffs, because no matter what happens, it ends up to be 0, at least in this binomial example. So with 2 steps. Now if you went many multiple steps, you could come up with a possible price, but it probably wouldn't be too much. Okay, so now let's go to another type of option, and those next option I'm going to cover is a look back. So let's do a look back here. Look back options, often known as no regret options. Okay, so investors, a lot of research has shown that investors often have regret from their past investment decisions. Because what happens is investors typically they fail to find the bottom to a stock, and they don't buy at the bottom. They end up buying at a higher price. They can't find the top in which to sell, so they end up selling at a price below the top. And because of that, they regret some of their decisions. And so what these options do is they allow you to try to get rid of some of that regret. But you're going to get rid of some of that regret, but it's going to cost you a bit. So these options, you can kind of feel that they're going to be more expensive than a standard option, because it's going to give you the ability to decide. It's going to give you the ability to take advantage of where the option went through the binomial path, how it went through the path. So let's look at the payoffs to these things. So we're going to look at, by the way, this is going to be a floating strike lookbacks. Floating strike lookback. And that for a call will look like a maximum of 0 versus the stock price at expiration minus the stock price at a minimum. So normally we have, with a call, you'd pay the strike, which is fixed. But here we can pay a strike that could be quite low if the stock dropped significantly during the life of the option. Okay, and so that could be quite valuable. With the put, you could imagine it's going to be the maximum of 0, stock price maximum over the life, which is normally the strike, which is fixed, but now it could be very high because the stock could have been fairly high during the life of the option, minus the stock price at expiration. Okay, so those are the payoffs. Now I'm going to create a new binomial to cover this. Yeah, so the example here will be, let's do stock price equals 70, strike is 70. We're going to keep the same U, the same D, up and down movement, the same risk-free rate, which means the probabilities for an up move are the same. They're going to be, probability of an up will be 0.581%, 58.1%. The probability going down will be the 0.419. It's going to be 2 steps. 2 years. 2-year option. T is 2 years, so it's 1 step per year. Okay. The lattice will look like this. Start off at 70, go up 10% to 77. The stock price here, another 10% will go up to 84.70. If it goes up 10, down 10%, we're going to be back at 70. If it goes 70 down 10%, 63.64, and if it goes down again 10%, 57.85. There is our new lattice work for the stock price. Okay, now just as a reference, your standard call, plain vanilla call, will have a payoff if this stock price minus the strike, 1470. 70 minus 70, 0. This is out of the money, 0. Okay, so those options depended only at the expiration, the point, the stock price at expiration. Now what we're going to do is we're going to do a floating strike call. Okay, floating strike call, and then we'll do the floating strike put here. Floating strike put. That'll be the next one. Okay, so let's look carefully now at these payoffs. And what we're doing here is we're going to use these payoffs, floating strike lookbacks here. Okay, so let's calculate this payoff right here. Okay, that'll be the maximum of 0 versus the stock price at expiration, which is 84.70, minus the stock price at the minimum of this path. What is the stock price at the minimum here? Well, it was 70 right at this point. Right here it was 70. Okay, therefore the payoff here is going to be 1470. Okay, now the payoff here, since we're looking at path-dependent options, there's two different paths to get to this point. So we're going to have two different numbers here to deal with. Okay, and the first one is the maximum of 0 versus where the stock price ended, 70, minus the minimum. What is the minimum of 70, 77, and 70? Well, it's 70, which means it's payoff of 0 in that spot. And then the next payoff is 0. 70 is where we ended up. But what was the minimum price? 70, 63, 64, 70? 63, 64. So this turns out to be 636 for a payoff. And then the next one is the maximum of 0. 57.85 where it ends up, and what's the minimum? 57.85, so that payoff is 0. So there's the payoff to a floating call. Now if you discount that back, okay, so discount this, multiply this by the 0.581 squared, discount it at 2% for 2 periods, multiply this by 0.419 times 0.581, the probabilities again, and discounted at 2% for 2 years, we would end up, if you did that, we would end up with a price, I'll put it down here, the price would be 626. And by the way, let me put that here, the price for the standard call would be $4.76 if you were to discount this back at the 58%, discounted it back 2 periods, and with a 2% discount rate, that's what you would get, 476. So notice what happens is the no regret option is a bit costlier. Why is it? What is the difference in cost between these two? Well, if you look at it, it's really this particular payoff is the only thing that's different. And so if you adjust this by the probabilities and discount it at 2%, you're going to come up with about $1.50 difference, which accounts for this difference in price of $1.50. Okay, and the reason is for the different, this is dependent on paths, and this standard call option is not. Okay, now let's look at the floating put payoffs. Okay, now the floating put payoffs, we are going to use this formula we saw before. Here's the put. It's the maximum of 0, the stock price maximum over its path minus the ending stock price. Okay? So for this particular payoff, first payoff, we're going to look at the maximum of 0 versus what is the maximum stock price over the path? Well, it's 84.70. And what was the stock price at expiration? 84.70. So that's 0. Okay, payoff is 0 there. Now, what about this guy right here? And then don't forget this guy. Two separate ones. And that's first one is going to be maximum of 0. What was the maximum over this particular path? Going up and then down, it was 77. Where did it end up? At 70. So that payoff is $7. Okay, and then the next payoff is 0. What is the maximum of this path? It's 70 minus, where did it end up? At 70. So the payoff is 0. And now let's look at the last payoff. stock price at the maximum of this path, this down path, the maximum is 70. Where did it end up? 57.85. So that's a $12.15 payoff. So $12.15 is the payoff. Now, if you discount these guys back, discount this back, adjust for the probabilities, and then discount it at 2%. Adjust for the probabilities, 41 times 40, well, about 41.9 times 41.9, discounted at 2%, like we did before, and we will come up with a put of $3.69 as the value of the put. And there you have it. There you have examples of look-back options. And again, so you get to see how these options are path dependent, and then you can compare and contrast that to the standard option here. The standard option just depends at the end. Payoffs just depend on the ends of the tree and not the path you get there. So that was the reason for covering those particular options. Now what we want to do is we want to cover barrier options. So that's the next option type, barrier options. And again, these barrier options are a form of path-dependent options. Okay, so let's do the barrier option. Okay, so barrier options, these are options that cease to exist. In other words, they die, or what's commonly called knocked out, or they can come to life, which means which is often called knocked in, when the underlying touches or breaches a barrier, a pre-specified barrier, and that barrier is often labeled H. Okay, and so these options, like I said, they either cease to exist or they come alive when the underlying asset price touches or breaches a pre-specified level during the life of the option. Okay, the thing to keep in mind is once these things become alive, they stay alive, and once they die, they die. And so what's interesting about these things is that if you have a standard call, plain vanilla call, that what you'll see is an up and in call, which means the stock price has to go up and breach the barrier, and it's a call option, plus a up and out call, which means if it goes up and breaches the barrier, it's knocked out, meaning it dies. The sum of the values of these two options is a standard call. So these things are important. As you can see, it's another way of pulling apart the pieces of a standard call option and breaking it up into these pieces. They're also important. Barrier options are also important because what they do is they allow you to trim off or chop off some of the payoffs that are either above or below the barrier that's specified. And so you don't have to pay for, when you buy an option, you don't have to pay for some of those, the probabilities of those payoffs, because the option may die if it goes up to, if the underlying asset goes up too far. So these options can be much cheaper for you. So let's do an example, and the example that we'll do is we'll go back to the old example we had a little while ago, where we had stock price was 100, X was 90, R 2% per year, U going up 10%, D going down 10%, N equals 1 step per year, 2 steps, or 2 years, T equals 2. Okay, and here's what we're going to do. Let me draw that out again very quickly for you. 100. Here we have the stock. We got 100. 82.65, and we have 90, 91s. Where we were before, we have a call, 31, 10, and 0 for the payoffs on a standard call. Now, what we're going to add to this, so that's the basic setup, which we've seen multiple times before. The value of this call is 1474, don't forget. So what we have to do is we have to add a barrier. So in this case, let's assume a barrier, H, is 105. Okay? And so the best way to do this, to visualize the effect, is let's actually draw a barrier at 105 in the lattice here. So 105 is about here. So I'm going to draw that H of 105 right at that point. Okay, in blue. There you have it. Okay, now what's going to happen is we are going to value an up and in call and then the up and out call. So let me do this. This will be up and in call, and then I'm going to do the up and out call. Okay, and so with the up and in, what that means is we start here at the 100 mark. When we breach the barrier going up, we breach the barrier, we go up, the option becomes alive at this right here at this point. It becomes alive and it stays alive. So it comes up, it'll stay alive, and it could have a payoff here to 31, or it's going to go up, it's going to breach the barrier, it's going to be alive, it's going to stay alive. Even though it comes down and crosses this barrier, it's going to stay alive for a $10 payoff. Okay, so now what we have is it comes up, it has a $31 payoff here, and if it goes up and it's alive, it stays alive. Even though it comes down, it's going to have a payoff of 10 here. And look what happens. If the option drops and it never breaches, it never becomes alive in these two branches here. So this path never breaches, so the payoff is 0, and this path never breaches, the payoff is 0. So now all we have to do to value this option is to discount the $31 back at the 58.1% probability squared times 31 plus the 0.581 times 0.419 times the $10 divided by the 2%. In other words, discounted at 2% for 2 periods, and we will get a call of let's see, $12. So this will be worth $12.39. Okay, now the up and out call means that when it goes up and breaches this barrier, it dies, and when it dies, it's going to stay dead. So if it obviously goes up, it's dead. If it comes up and it even goes down through the barrier, it's still dead. So what we have here for the payoffs will be we'll have 0 because it's dead. We'll have a 0 because it's dead. And now it's alive here. And it comes down and it comes over. And it's going to have a $10 payoff because remember, it's a call option and it's S minus X. So it's 100 minus 90. That's our $10 payoff at that point right there. Okay. And then here, the option, it's a call option that never pays off. It ends up at a price below its strike, so the payoff is 0. So now what we have to do is discount that 10% back by the probabilities. Discount it back, adjust it for the probabilities, discount it back at 2%. So it's 0.581 times 0.419 times 10 divided by 1.02 squared, and we get $2.34. And when you add those two up, 2.34 plus the 12.39, you get $14.73, and I'm off by a penny due to rounding. So pretty cool, huh? These up and outs, an up and in plus an up and out call equals a standard call option. And there you have it. Again, another path dependent option, in this case with a barrier. Now, this is a very simple model. It turns out that if you have more complex models and you want to do a really good simulation for this to price it, it becomes quite difficult because it depends where these barriers are relative to the various nodes that are out there. And so there's a lot of literature written on the complexity of those simulations. But it turns out, from what I understand in looking at the literature, is that, and I've worked on it myself, you're probably better off if you can superimpose the barrier to be at a particular node. It makes it a bit easier in the simulations and for the pricing.